hope you will love the tool, love what we're building. And yeah, without further ado, let me jump to, can I share the screen?
Yes, please go ahead.
I think I don't have the access.
Oh, give me 1 second. Yeah, try now, please. Okay, it's coming up.
Okay. Can you see my desktop now? Okay. So good. As we'll be talking about a couple of things. So, but the workshop is mainly about the tool that we've built at Hexens, which is called Astria. This is the scalable smart contract vulnerability tool. I'll just dive deep in a couple of moments. Let's do the intro. So, my name is Vahe. I also go by the nickname Cameo. I'm co-founder at Hexens. And also Remedy. In a couple of words, I'm a Web2 security guy transited to Web3. I like very much playing CTFs. And that's about me in a couple of words. And let's talk more about the tool that we've built. Like, what is Astria? Astria is a variant analysis and security researcher tool, which we believe to be actually like one of the most, if not the most powerful tool that you can get in the Web3 security field now, and you just have a look of what we're building. Let's say Astria is a tool that helps you to answer the following questions, like how to find all contracts that have reentrancy, or how to find all contracts that can be self-destructed by any caller, or how to find contracts that you can describe any vulnerability or any scenario, and you can find these contracts throughout all of the deployed contracts on blockchains. Let's say Ethereum, Optimism, Polygon, doesn't matter. Like this right now working on EVM-like chains. Yeah, but like the idea is that you can query Solidity and Viper contracts for any scenario that you want. But of course, from a security engineer perspective, the main emphasis will be security research and variant analysis. So from a bit more technical point of view, Astria is a smart contract query framework. And the querying is not based on semantics. Like if you're familiar with SemGrep, which is let's say grep ++, or so it's a semantic grepper. So it's not working on semantic level, but rather we're working with compiled units, which helps achieving more functionality and the highest accuracy that you can get, because it's not based on the semantics how the code is written, but it is like working on actually compiled unit. So what other important parts is that, so we emphasize the robustness, and so the queries should be very fast, and also it should be very easy to learn this query framework. That's why it's like almost the same as writing Python. You don't need to learn any new languages to understand how to write these queries. Only thing you need to know is the framework functionality, which we have documentation for, and we'll be talking about this a bit later as well. So it's a good learning curve, we believe, and it's also fast execution. It is graph-based, and a lot of query types that you will be doing is based on a little bit of knowledge. Like not all the queries that you will be writing will need like data structures and graph knowledge, algorithm knowledge, but some of them might need it. So this also simultaneously answered the question why we included, let's say, some basic Python questions and also some algorithm and graph questions as well. And we tend to design this as this query framework as very flexible, so we can integrate into a lot of other different security tools that you can imagine. And we'll be talking about this as well. And of course, so the main idea behind this is that we want to give you all the functionality so that the limit of the tool is only like your imagination. So this is a simple query, just a basic one, and let's have a look, and I'll explain you like what this actually means. So let's say we want to a very easy query. Let's find contracts that call self-destruct. So basically, we have here the first line. You can just emit it. Actually, this is for a better IntelliSense when you write, so you can get all the suggestions and all the tooltips for functions. But basically, this is if you worked with the declarative libraries, you should be familiar with this kind of DSL chains of queries. So we start querying all the functions in the world. We filter them with called function name self-destruct, and we execute the function. So, and we return this array. So we will actually get all the contracts and their functions and the instructions that are calling self-destruct in all of the deployed contracts on any chain. So right now, the thing that so the version that we will be showcasing you is deliberately working only on Kovan network for mainly like one reason is because the Kovan network is deprecated, and we believe that for learning, like during the learning of this query framework, we don't want people to actually find contracts that are vulnerable and have some money on it. So we want to give you like a simulated environment where you can query a lot of contracts. Like Kovan is quite a big database of contracts, but still we want to make sure that we're not affecting live contracts while people learn this. So yeah, so a little bit of breakdown as I already did, but like once more, the first line is just an import. This is for IntelliSense. You can actually omit it. It's not necessary, but there are some parts that are needed to be kept in the syntax of how the query works. All the queries go into Python function called query. So you will have this when you open a strand. You will see like it always starts with the import and the def query. So all the logic goes into this query function, as this query function will be called. And another important part here is that to see an output, you need to return a list, or let's say array, of objects that you have filtered in any way. So this is how it basically works. So let's say we go into a bit more complex query. This is still like not super complex, but it's a bit more sophisticated than the last one. Let's say we want to find all the contracts that call self-destruct, and they have some other call before that as well. So here, so this example is given for you to understand that there are the query is always like it can be consisted of two parts. The first one is the declarative part, where you work actually with the GraphDB, where you query a lot of data. And this is one of the reasons why we use the Python-like querying, is that you can write arbitrary logic, you can filter them arbitrary, and work with the graph of the objects that you've queried. So let's say like we have with the first line, this is a better breakdown of the query. We have the first line that actually returns all the instructions that have self-destruct call. Then we iterate over these instructions, and we have a special function on every instruction that you can be called on every instruction is called previous instructions. So this actually returns us the previous instructions that come before this instruction. And this is done also, this is not done semantically. This is all done on compiled units. So if there, like technically some instruction comes before this, but it is not into control flow of it, so you will not be getting this. So yeah, we iterate over previous instructions. We check that if it's a call, then we're saving this instruction as it's something that we wanted to actually filter out. And we just, at the end of the query, we return the list. So just one more part. As I already said, the query can be broken into two parts. The one is declarative, and the second one is imperative. The declarative is the one, let's say, we also call it online part, as it's actually querying some GraphDB that we have. Like this is like a custom configured GraphDB that we have. And where you can filter a lot of things. And you have offline part, the arbitrary logic part, where you can do a lot of filtering, like you can check a lot of logic, very complex logic, whatever you want to. So GraphDB mainly, it's mainly for a very performant filtering of high-level entities. So this is, let's say, the most high-level entities that we keep. This is not the full list, but this is mainly the things that we keep in our GraphDB. It's contracts, functions, modifiers, instructions, all the structures that are defined there, the enums, errors. These are the custom errors. Yeah, and we have errors doubled in the slide, but yeah, so whatever. So one of the most important. So we have a question. Oh yeah, sure.
Okay, quick meta question. So for anyone who has a question, would you want them to interrupt at this point, or would you sort of pause in a?
We have I have like a Q&A slide at the end, but I'm totally okay if you want to ask questions on the fly, we can do that as well. So I'm good with both.
Okay, so yeah, maybe if anyone has questions, please use the raise hand control that you would see on your screen, and then we can take it. Yeah, I think we already have one.
Yeah, good.
Hey, thank you, Rajiv and Vahi. Okay, so I just don't have the complete idea regarding the compiled units. Like I have an idea like about semantics, but how do we deal about searching with compiled units, and what exactly compiled units are?
So basically, what I thank you for the question, and what the idea was behind explaining that it's not semantically querying, but querying on the compiled unit is that so we don't find, let's say, we don't define that something is a function because it's like semantically looks like it is a function, but rather we instrument the Solidity compiler, and when you give a contract to the compiler, we're extracting all the information from this compiled unit. That means that if something compiles into a function, then it's a function for us. Let's say if you write, let's imagine a situation that you write a function that can be compiled into a real function in Solidity, but you put it in comments, right? If you try to find it semantically, if your semantic searcher is not working correctly, you might end up actually thinking that this is a function as well, because it looks like a function, but it is included into a comment section. So in our case, we will not be having this false positive because we're extracting all the information from the compilers. So in that sense, the person who is writing query, who is working with the tool, he can be agnostic on how exactly are we doing this, but I'm just trying to also give a bit of more technical information so that you will not be thinking that, you know, maybe this is only querying semantically. If I don't know, put it in some section that cannot be compiled, I still will be getting all this entities or whatever. So no, you will not be getting this. And let's say if you wanna if you want, like, theoretically, of course, you cannot have non-compilable contract on blockchain, but let's say if you try to give this tool a contract that is not deployed on blockchain and it's non-compilable, you will not be able to actually start querying on it because it's not a correct smart contract. It needs to be compilable so that we can extract all the information from it. So this gives this brings the false positives to zero. So you will not be getting any entity that you query if it's not really there. So that's the main, like it's the hard way to go. Like you have SameGrep for contracts. You can use the SameGrep for contracts. It is an open source. There is an open source tool that you can SameGrep your own contracts on your hard disk, but it's not the same here, right? So that's mainly the difference when I'm telling you that we're working on compiled units rather than on semantics.
That makes sense. Thank you.
Yeah. So the reason why we went with the Python-like syntax, a bit more info on this. So this makes framework very flexible. Like you can technically include a lot of, let's say, third-party tools into this as well in the future. Right now, we don't have this feature; it's still in the development. But like this is, if we have this in the architecture, you can be able to integrate a lot of different tools here. And this takes off part of the computation of the DB, and this actually your query is dispersed into online and offline mode, which brings us into a situation where we have very robust queries. They are working very fast. Like you will see on your own, like querying something on whole Kavan network, which consists of hundreds of contracts, will be extremely fast. Some, let's say, finding this self-destruct queries, finding let's say the first 100 of them, it takes only a couple of seconds. So yeah, you will be playing with it and you will see. So, and the query this is not a full Python, so you cannot do whatever you do in Python. So it's running, it's sandbox, it's not the full Python, plus it's working in a sandbox. This is done for security reasons, of course. So there are a lot of things that you cannot do, which you do in Python. Let's say you cannot import any modules. The only module that we have that can be imported is the Astray itself. This is for the IntelliSense. It will be working without it as well. So there is no imports. There is not a lot of things in Python that you might need if you're just writing some scripts, but you have everything you need for writing arbitrary logic and writing the most complicated queries. There are special limitations. I have to talk about this. These are done both for security and let's say availability reasons. So queries have timeouts. It's 1,000 seconds per each DB request. So let's say if you write a query and it consists from a DB query part and arbitrary logic part, all the DB queries will be timed out after 1,000 seconds. But that's a lot. I think you most likely will not be needing to wait for 1,000 of seconds unless you have built a really complicated query for DB. And overall, the query can work for 2,000 seconds. That's almost like a half an hour. And your output limits is around 200 kilobytes. This is done for a reason. If you just, let's say you want just to return all the instructions or all the contracts there are, you will not be able to see them in front end anyway. So we're limiting your output to something which is still a big number, but at least it makes some sense. I think we have a question, right?
Yes. So just a quick question. So in the previous slide, we have at the end we have dot exec, that is execute, right?
Yeah.
And in there we have a parameter. Is it Is it the timeout or the number of records that we want to get, or something else?
Yeah, I would be talking about this exact part in a couple of slides, but yeah, you're right. This is for limiting. The result amount. So if you write exec, so you gotta. I'll be talking about in a minute, but you gotta write this exec at the end of your query, so that the query engine understand that you have completed your DSL part, and you can. If you don't pass any number, it will return everything. But sometimes the experience shows that sometimes you want some pagination, let's say, for the results, and that come from DB, because let's say you find 10,000, or even you find 1,000 vulnerable contracts. Okay, you will not be able to analyze all the 1,000, I don't know, prepare a report or understand whether there was any mistake in your query and this is not a false positive for the 1,000 in any like in any time, let's say in the day or something. So the experience shows that you need some functionality so you can paginate through the results, and yeah, this is one of the way how you can do it. Yeah, so let me, can you see my screen now? Can you see the UI? Okay, great. So let's say, so this is actually like how it looks. You can have like a light mode and dark mode. Yeah, we have a question. No. Oh, okay. Yeah, let's say I want to query all the first, I don't know, for all the self-destruct contracts, and I want to limit it to the first 1,000. I just run the query, wait for a couple of seconds, and we get the result. So you get the result here where you can see the contract address, you can see the function where the instruction was found, you can see the instruction itself, so you can understand which one you filter out. So yeah, and this is not the only entity, of course, that you can query. This is just a showcase for this. Here in the lower side, you have some profiling info, so you can see how many megabytes of the peak memory usage of your query. You can see like how many results you got, and approximately how many seconds your query took. Yeah. Let's say we want to query for something else. I don't know. Let's see. And query some. So yeah, one more important thing. So we have documentation for the API that you're using. It can be found with this documentation link on the left side of the website. So this is generated documentation where you can find all the entities and what functions they have, and some short description over it. As we're working still on like a more detailed documentation, but it takes a lot of time, to be honest. So at least we wanted to give you all this this documentation, which actually helps a lot on its own as well. But yeah, we'll be writing like a Gitbook documentation for this as well. So let's see, I want to filter functions by, you know, with some name, or we can filter it with modifier names, with a lot of stuff. So you can play, when you play around, you can see all the filtering functions. Yeah. Let's say we find all the, okay, with name, and let's put here, let's draw. This time, okay. So we can we found all the functions that have withdraw name. So let's say I want to filter these ones with, let's say I want to only keep the ones that are externally callable. That means they're either public or external. So we can go here. We have this beautiful one property, use this function, and we have a special method prop object here, for public, external. It's actually a good idea to, yeah. So we only filtered out to the functions that are that are publicly callable. And let's say, okay, let's query for some bigger numbers. Yeah, you can see that whatever we get is public and external. And let's say I want to filter out the ones that have non-reentrant modifier. Okay, so a nice way to do it will be to write without properties, and we have a special property for that, which is called has modifiers. Oh no, sorry. Let's okay. Let's do it like this first. Has modifiers. Yep. Made a mistake. I don't know. It's not letting me do it for some reason.
I think you missed the backslash.
Oh yeah, sorry. Yep. Thank you.
And why possible to zoom in a little? I think.
Oh yeah, sure. Just 1 second. Okay, is it better now? Okay, is that any good? Okay, so what we did in this is basically one line, but like we broke it into a couple of lines so it's more readable. But we're filtering all the functions in the world. We filtered them with the name withdraw. We filtered the ones that are public external, the ones that have no modifiers. Okay, and so the first, I actually just wanted to filter out the ones that had non-reentrant modifier, but this is something you can query as well. Yeah, it's much better to change clarity. So you can analyze all the output that you have here, and you can take the address and check it on the Common network to see what you want to do with it afterwards. So there are a couple of features that I can tell you about now. So there is a very as this query works on the sets, it is very important for the, let's say, for the query to be fast, so that we filter the entities from top to bottom. Let's say that I want to filter out the functions, then I want to filter out some instructions. So let me show you how you can do this. So we have these leveling functions, which so right now, whatever I was writing at this part, this was working on the functions entity. And let's say I have already filtered out the functions that I want to. Now I want to filter out something from their instructions. Okay. So let's say instructions. Yep. Let's see. Query for the instructions. Let's say that we have some recalls, low level calls. Okay, let's see. I'm not sure that we have anything with low level calls, but let's try to find out. Okay, so low level calls and it's called function. Better to with the call. Okay. So now I will be filtering from the already filtered functions. I will be filtering their instructions. Let's say I want all the ones that call, I don't know, let's say balance off. not even sure that there are any with this, like this kind of functions. Oh, there are. Okay, so we have the functions. Here is the instruction. So we found the instruction. Let's start from the very beginning. This is a withdrawal function. It is public. It has no modifiers, and in their instructions we have a call to a function called balance off. So and this is the instruction, and we can see it. It starts with it. Yeah, like oops. Like for here, see, we have found this call of balance off in a more complicated expression. It's inside the require function call, and yeah, but it's still found. This is one of the ideas why I'm pointing out that we're working on compiled units, is because if you want to try to find function calls semantically, there will be a lot of cases where you will be getting false positives, which is not the case if you're working on compiled units. So whatever they are called, you can find calls that are done in assembly. You can find calls that are done inside other calls. So yeah, you can do whatever you want to. So yeah, and there is, so when you get this results, you can start working on them as well. So if you, let's say if you go to the documentation, you can see that this, when you execute the query on the instruction level, you will get an array of instruction array. So the querying entity, it's always in the plural form. So if I'm trying to filter out functions, I call functions. If I try to filter out instructions, I call instructions. But when I execute the query, I will get like the singular form of the entity. So I will get an array of instruction type of entities. And you can take a look like, okay, so now we're getting instructions, right? So what we can do with this one. So we can work with data flow, which is, these are a bit more like complicated aspects, and we will be having workshops on this parts, like how to write more advanced queries, how to work with the control flow and data flows of the graph. Yeah, but basically you can do a lot of things here. Like you can, let's say, and oh, I forgot you to also tell how our print works. But yeah, let's say, just for the sake of this example, we do have print functionality here. This is mainly for debugging reasons, so you can debug better your queries. So as I limit it to one result, but still, like, it returns me an array. I will just have one element there, so I still need to index it as an array. And let's say I want to print the destination. See how it works. So here is our this print functionality. It's only for, like, it's for debugging. That's why we're so how you will see this print output throughout your query, and it comes as the last object from the in the output. So basically, this destination, it will give you, so it will give you the balance object, but it is it is not a string. It is a special object. So you'll need to take a look of how to print it to actually see what's the part of the instruction there. So yeah, I mean, I can go very long on what you can do with this engine. There are a lot of functions, a lot of applications for this. You can do a lot of stuff at this, as you understand, like basically any logic can be implemented here, and you can see the how fast the queries are executing. Like it's basically working on all the Kavan, and you're pretty fast on querying on whatever you want to. So this is like the basic introduction to the tool. And in future workshops, we will be I will be explaining you how to work with an more advanced functionality, how to work on the graphs, how to taint. So one of the important features that we're going to have is the taint engine. Let's say that, so I'm not going to show it right now, but let's say, with this functionality of taint engine, if we filter out all the balance of calls, we can check that, let's say, the balance of argument is tainted to to one of the external arguments, or some specific external arguments, or it's tainted with message sender. So yeah, that's more complex logic, and we'll be having workshops for that separately. But that's, yeah, I mean, what we're gonna do on our workshops, and not only workshops, like we're gonna do some task-like activities. So we're gonna propose a vulnerability, and we will tell you guys to write the best query you can, which can find the most of the vulnerable contracts, and which has the best ratio for false positives, which works the faster. So basically, we're going to rate, and we're going to analyze and understand why it's working better than another query, and so on and so on. And so, yeah, there's still a lot that we can do with this, and I think you can imagine already. Like the applications that you can get from this tool are just like, they're too much to imagine just for myself. So yeah, you help me out. And of course, as this tool, like I guess I need to talk a bit more about high levels of like, how do we imagine this tool we're going to be working. So this tool will be available for the community exclusively on our security platform called Remedy. So, but you don't need to. So it's not paid. It's a free tool. Everyone can use it. There will be tricks, but like it's not a paid. You will not be have any paid version or whatever. Yeah, you can use it in Remedy, and you're the first people outside of, let's say, Hexens team, or people that we have shown this. A couple of people have seen this from the community. So you're the first people to try it out, because from our perspective, as we're building a community tool, a tool that the whole security community will be using, we need your feedback. So we gotta understand what function. Maybe there's some functionality that we miss, and you want to see it. Want to understand like how it works on when a lot of people simultaneously are querying it. So yeah, we just basically want your feedback, and to iterate it and to make it much better than it was at first. So yeah, thank you so much. I'm eager to answer all your questions if you have. Yeah, you can go ahead.
Go ahead, Ostap.
Okay. I have two questions. The first one is, where do you get all the source code for the contracts?
Yeah, so that's the one of the tricks. So we basically work with the explorers. So you got to know that there is no source code on blockchain, right? There is no source code. The only place you can find source code, which is verified, is the explorers. So we work with the explorers. But there are lots of tricks. So when we first, like back almost 2 years ago, when we just started writing this took us 1.5 or 2 years, something like that, like developing these first versions. So we're thinking that if you get smart contracts out of the explorers, you can compile them. This is not true. This may sound very strange, but they're not compilable straight out of the box. Maybe half of them are compiled, like 50%, yes, but you miss the rest. You miss the half. There are a lot of things that you need to be done, so that the contract code that you actually get from the explorer will become compilable. And as I already said, like, we want to work on compiled units, not on semantics.
Yeah, okay, great answer. Actually, my second question is also connected to this one about source code because I want to know how you deal with U contracts that don't have functions or modifiers. They have only instructions. Can you still query them?
Yeah. So let me put this way. So if a Solidity compiler can compile it, then we can query it. So it's yeah.
Okay, great. But without source code.
Yeah, yeah. So basically, you can do it, but as you said, so some of the entities will be missing. So I don't think that it's will be like too effective, but it's technically possible. Yeah.
Okay, great. Thank you.
Mhm.
There are a couple of questions on the chat, Vahe.
Oh, yeah,
Maybe I can read it out for you.
sure.
So the first one is, can we use this for offline projects which are not deployed yet?
So yes, this is possible. Like it is possible to use it, use this tool for offline projects, but not with not with this version. So let's say we started with actually working on local projects when we're still in very active phase of development. So it is possible, but I think the beauty of the tools is that you can. So I think the beauty is on the scale, not on like it's not too it doesn't have too many applications if we're talking about like just a local environment, but there's something that I can tell you about. So basically, if you let's say you're an auditor and you have your favorite checklist of 50 bugs that you mainly want to check out on the contracts, so you can actually create these 50 rules and you can scan it on your local base. I think that sounds really great. Yeah. So yeah, I just come up with a nice application as well. Yeah, it is possible, but not with the current version. The version that is working right now is this is a scalable version. It works on the scale of blockchain or blockchains in plural, and I think it's much more interesting when working in this mode. That's why we started delivering as in this version. But yeah, like it will not take us too much time to also deliver a version that works on local projects. Hopes that answered your question. Yeah.
And I think there's one other, well, a couple of related questions from TA Dev, whose microphone doesn't, or who doesn't have access to a microphone. If I can summarize, it is related to Astria working on compiled units, and the question is about how can you get the function names and how do you avoid clashes, right? So if with function names or with modifiers, do you get any clash, or do you treat the results under the hood to eliminate false positives, or maybe there is some other magic going on?
Yeah. So I didn't get the question fully in the sense that what kind of clashes are we talking about? If you let's say if you query a function based on the name, I think the example was based on the name, right? So if you query for a name, you will only get contracts that have that name. And by the way, if we in some other sense, if we're talking about the clashes, we have used this tool to find a real real deployed selector crashes for contracts. But so if you have a contract that is compilable and it has different functions that collide in their selector, they still don't collide on the names, right? So, but they may collide on the selectors. You most likely they'll not be compilable, but we still have both the name and the selector. Once we've write a query that went through all of the Ethereum mainnet and we found all the clashes for the function selectors, that means that different function names they actually have the same selectors. So you can even do these kind of queries to find worldwide clashes of selectors. But I didn't really got like the part of the question, like what should be, what even should I don't know, should give me any trouble with the names colliding. Like I don't see any troubles, and you can freely query it without any false positives.
Yeah, I think that is my understanding. Well, based on your explanation, that's my understanding. So I'm not sure what TADEV meant. I mean, he gives an example of self-destruct. I guess the compiled unit could correspond to another high-level function name with, well, another high-level function with the same name as self-destruct, I guess. But I
Oh
don't know
yeah,
if the,
okay. I got it. Yes, this is the beauty of working on compiled unit. That's it. So we have different functions. Okay. Now I got it. Yeah, this is a very good question. Like, let's say we have a function that is called self-destruct, and you also have like a built-in function called self-destruct. Although I think maybe compiler will reject it as if self-destruct is in reserved words, most likely. But let's say there is some case that where it does not reject, so we can actually understand which self-destruct call is the built-in self-destruct and which one is let's say a public function or internal function or whatever. So you can we have the type of the call, we have it in the database, and you can actually understand like which call are you doing. You can filter out, you can use like you can filter with built-in function calls and find self-destructs there. Yeah. And this one, this is a very good example of on why querying on semantics is not the best idea. You can never understand whether this is a built-in call or this is just a high-level function which just happens to have the same name.
got it. Well, if people have other questions, feel free to raise hand. If not, I'm going to continue to take a few questions from the chat. Just one, maybe one other question is, okay, there's one on defining variable. Is there a limitation in defining variables?
Oh, I can see.
And
You can,
can you, yeah,
yeah,
if you can open, then it may, okay, good.
Yeah, thank you. So I think this one is so there is a way to understand whether two instructions are equal or not, but it's not directly the way that you wrote it. You also have like something called ID. You can check the IDs, like if F10 ID equals F20 ID. Yeah, but I think we will be covering this kind of things on future workshops as well, and or you can ask any question in the Discord channel, like this kind of more technical ones, like practical ones, let's say, like how do I call this or that, and I'll be eager to answer all of that questions. Yeah. So thank you for Major. Thank you too for coming. What is your vision on this product? Will you open source this and or make it like Metasploit in Web 2? So I think with a very high probability we will open source at least part of it. We might go I don't think that we will go full open source, because this is the thing, like there is and also the complexity of this product is not only the framework that you use, but there is very big and complex architecture behind it. All this stuff with DB, we have a very big like microservice pipeline that works with the contracts, so that we can extract all we want to. And so there's a lot of infrastructure behind it, which is like you cannot really open source it in a good way. Like you're gonna have, I don't know, 30 repositories for that. But with the main query framework, I think that was our initial idea. We want to open source it so that people can also contribute it with their functions and functionality. Yeah, so that's basically it. Like how do you achieve queries? Oh, I think we have a question here, right? You can go ahead, and then I can continue. Yeah, reading the other ones.
Go ahead. Is that 0x Umar? Katab?
Okay, sorry, I was typing there. Okay, just a question on your starting note. You said that this is only available on Coven for security reasons,
Yeah.
but is it right now? Is it available on like the mainnet or other chains?
Yeah, like,
Just a question.
yeah, we do have a version that an internal one that works with the Ethereum mainnet. That's actually like one of the reasons we didn't give right now the mainnet as well. Apart from security considerations, is that Ethereum mainnet is the biggest chain actually, like in all of the. I think in all of the world, and especially in EVMs, like it's too big. It may be 7 times bigger than Coven, something like that. And we're still working on making the queries work as fast as you will get on Coven for the mainnet as well. And it's one of the things that we're actively working on now, because we want very good developer experience with queries. Yeah, sorry. So yeah, we do have a version that works with Ethereum mainnet, although it's not like actively, we don't actively update it on purpose. So we're not right now in a process that, that we want to find a lot of bugs and report all of them, but we want to work with a very big database and to optimize the work of the product. We still have all this set up internally, right? We can do it anytime we want to, but I think it's much more impactful and important to actually deliver this product to the community, so we're not rushing on going and finding bugs by ourselves. Yeah.
Great, that's a good approach. Thank you for clarifying. And the other
Yeah,
thing
thank you.
is this link that you were trying on your end, astria.hexens.com? Is it
Yeah,
working
yeah.
for
It,
everyone's?
Yeah, yeah, it is. It is working. We just have a basic authentication on it, but this is done just for a reason of indexers or other scrapers not to automatically scrape it. That's the only reason. So as we come up with this number, the exact list of participants, I will be sending out the credentials so anyone can work on this link. It is astriahexens.com right now. Yeah.
Perfect. Thank you.
Yeah, thank you too. So I'll go ahead with the rest of the questions. Thanks for amazing product. Okay, how do you achieve queries by function name or modifier name? Is it compiled code? Don't you get any? Oh, this was the question. Okay, or it wasn't the same one? No, I think that was the same one. I already answered.
Yeah,
Yeah,
it was
yeah.
the same one. I think it was in 2 parts, but we can go to the next
Yeah.
one.
Ah, yeah. Okay. Can you query the state of contract? Yes. So basically, the version that you will be seeing cannot do it, but this is the first big feature that we're delivering. We're working on it right now, so that you can query the state as well. And this makes it will not take too much time. We're waiting it to be delivered in the near future. And yes, I think this will bring this query on the next level, actually, where you can find, let's say, vulnerable contracts. Then you can find all the protocols that work with the vulnerable contracts. And yeah, I think it will be. We've thought of that as well. So yeah, we're working on it. And in near future, we're going to deliver that functionality as well. So what we're thinking of as besides this, as we have went with very flexible architecture and using, let's say, Python-like framework, is that we can integrate a lot of things into that. Let's say you can integrate symbolic execution or fuzzer into this framework. You can query for some contracts, filter out the ones that you're interested in, and you can run a fuzzer on it. So yeah, that's just one of the things that this kind of architecture is able to give you. Something that can be included in the instructions. So modifiers have their instructions as well. And you have a special function to query for the placer, so-called placer instruction, the underlined one, where you use this in modifiers to actually, let's say, inline the function code as well. You can use this functionality to let's say find all the modifiers that are working like reentrancy locks, where you have a storage variable set to 0, then you have the placer instruction, then you unset it. So you can actually write a query and find all the modifiers, and you can think of some other scenarios as well. Sometimes you can see modifiers like reentrant modifiers not only flipping the flag, but some of them are incrementing. So you can include that logic as well. You can find all the modifiers that are actually blocking the reentrancy, and you can filter out some function if you're trying to find some reentrancy attacks. You can filter out with this list of modifiers instead of going, let's say, more syntax-based or semantic-based approach, saying that exclude me all the modifiers that are named non-reentrant or lock. Of course, this is a good approach as well. And to be honest, we're using that kind of queries a lot, and it works like a charm, because actually it really is like just a couple of names of modifiers that are like they're mainly used as non-reentrant. When you filter those out, you're only left with some very small amount of edge cases which you can then just include in your query as well. But yeah, I mean, more proper way to eliminate false positives will to go through the modifiers, file on all the ones that are working like reentrancy locks, and then filter out those. Yeah. You can see opcodes in the command to know that self-destruct is used. So yeah, I mean, actually the compiler knows when it's compiling the code, it actually knows that this self-destruct is a built-in function call, and we extract this data from the compiler. Is it live on other chains? Yeah. So you can experiment, and this is one of the reasons why we're here. Does Astrea work for contracts verified and unverified? Of course, it does not work with unverified ones. There's so the reason behind it. So here it is. We work only with the verified contracts because first, I strongly believe that a lot of information is in the source code rather than in bytecode. The bytecode analysis, it has its own place. Of course, you can write some tools that works on the bytecode analysis as well. But if you're working with bytecode, you lose too much information. You basically don't have any information apart from just pragmatic execution flow information of this opcode is run, then this opcode, then this branching or whatever, and this is returned. You have nothing. You don't know anything about the function names, about the modifiers, about instruction flow, about the taints. So not all the taints, but yeah, whatever. We're working only with the verified one, and also, to be honest, I have this very strong belief, and our statistics, and not only ours, shows that if a contract worth even anything to analyze it, it has verified code, right, on the Explorer. So apart, let's say, of some MEV bots or that kind of like exotic stuff that might end up be helpful to analyze, let's say you'll never see any protocol going live that worth something, that have some money on it, and it doesn't have a verified contract. So I think this filters out automatically to only the contracts that you might even be interested in analyzing. And yeah, of course, unfortunately, the compilation for the bytecode of Solidity is still an open question, and I really like, excuse me, Dedaub's decompiler. I think that's pretty much the best one you can have from decompilers, but still the decompilation is still an open question for a lot of languages, even outside of Web3. Like, you still don't have good ideal decompilers. It's impossible to have an ideal decompiler, right? And a lot of times, especially with Solidity and Web3 languages, when you have this decompilation, even with Dedaub's one, which is as I say, I really believe it is the best one we have right now. Like most of the cases, the code decompiled, it is readable by the one who is decompiling, but it's not compilable. So you just have, let's say, for all the memory accesses, you have this uppercase letters mem, but it's not compilable. Like you get a code, you can read it and understand it as a human being, or maybe give it to AI and it will understand a bit as well, but it's not compiled. You cannot compile this code. So yeah, that's on the verified and unverified. Can you access the AST of the unit queried or the contracts containing? So you can actually access a lot more than just AST. Yeah. So in terms of graphs, like working on graphs, different trees, let's say, not graphs, or not just graphs, but like let's say the AST, the CFG, DFG, you have a lot of functionality that you can take a look at the documentation. So yeah, technically the answer is yes, and more. But I would say that you can do a lot more than just querying AST as well. Yeah. Okay, thank you all for the questions. Maybe there are any other? Yeah. Yeah, go ahead. Sure.
Okay, just a final one. So, what are we like? What should we expect at the end of this workshop?
So we have so firstly, you get this quite unique chance to actually play around with Astrea apart from Hexens team. So we have prize pool, or we'll be having this, let's say, a contest of queries, as we're going to be having some tasks, and you will be contributing the queries that you think are the most well written, which are performant, which have the best coverage, and like the best false positive ratio. And basically the top 3 people, based on how many queries and how good these queries were, will be rewarded. Yeah, we have $6011 in the pool. The first one gets 3337, and the second and the third places will get $1337. So it's elite. And
Yeah,
we get, like, from our side, we get a lot of fun, and we get all your feedback, which is why we're doing this on as well. Like it's super important for us to get the feedback and to iterate over it.
Yeah, thank you for telling me the incentives part. I was actually asking about the technical part. Like, will we be just exploring the Astrea, or like on just Coven or something else?
Yeah. So it will be exploring the Astrea on Coven. So most likely will not be introducing new chains during the workshop, but we might be introducing new functionality. So let's say if we get a very good feedback on some functional that can be delivered quite quick, we might end up delivering it even through the workshop. So let's see. And also, I just forgot to say, of course, like you will get the chances throughout the workshop based on your performance. We're eager to do interviews with people as well, and who knows, maybe you'll be one working on Astrea internally at Hexens as well.
That's great. Thank you.
Yeah, thank you too.
Awesome. I think we definitely have a lot of time during the next 2 weeks for a lot more questions and feedback for Vahe and the rest of the Hexens MD team on Astrea. So let me pause there, and I guess there are no more questions, right? At this point, okay. So cool. So thanks, Vahe, for well, as you mentioned, for this exclusive introduction to Astrea, to the Secureum and the Hexens communities. So definitely sounds like a very, very interesting and promising tool that we will definitely learn a lot more about in the next 2 weeks. And with that, was there another question, or maybe we can? Okay, maybe we can take that later. But yeah, so thanks to Vahe for that, and for everyone else on the call. Just a couple of, again, logistics and operational stuff, right? So please stay tuned to, at least for now, to the Secureum Discord channel, the private channel that all of you have been invited to on the Secureum side. So there will be well, a lot of the things that regarding the workshop, the next steps, the timeline has been shared, at least at a high level on that channel. And just please stay tuned, enable notifications for that channel. There will be a lot more, announcements coming there, at least till tomorrow. And after that, we will, probably have sort of a migration plan. We'll figure out a better way to coordinate as well on the Hexen side for the remaining duration of the workshop, right? So all these details will be shared at least till tomorrow on the Secureum Discord server. So please stay tuned to that. And maybe Waheb, given that we are recording this, I think one of the critical things of this workshop is that the participants obviously get exposed, get introduced to Astrea, and for the Hexens, it is not just getting a lot of eyes, but you would like a lot of feedback, like you mentioned, right?
Yeah.
So can you maybe just touch upon the types of feedback that you're looking for? I'm sure there's a lot of stuff. You've been building this tool
Yep.
At least for 2 years, right? So UX, there's a lot of technical stuff. There is all the querying, there is documentation, there is all kinds of stuff that you can do. But maybe if you can summarize sort of the top things that you would expect or you would hope for feedback on, what would those be?
Yeah, so I would say that, of course, apart obvious maybe that we missed some bug, like that's obvious, but that's not this is not a QA session, right? It's not like too important for us. The most important is, I guess, the features. Let's say that when you think of a scenario or vulnerability that you want to query and you feel like you're missing this feature, you're missing a function, you're missing something in the query engine that will help you to do that. That's the most, I think, crucial feedback that we're thinking of. It we would like to see is like the features that might be missing. So, and then most likely they are, because I think we thought of a feature that we can come up with. Some of them are still in development, like we know about them and they're still in development as they're more complex. But I think this kind of feedback is the most valuable for us, when you will just think of an application for you of this tool, and you think like something is missing there that can make it happen, and we are eager to make it happen. Yeah, and thank you one more time, everyone, for passing the race, for coming on the workshops. I'm really looking forward to this 2 weeks. I think it will be a lot of fun. And thank you, Rajiv, one more time for hosting us. Yeah.
Absolutely. Yeah, so there is, I think, a lot of stuff planned for the next 2 weeks. So for all the participants, there's an amazing opportunity for you. And like Vahe said, this is really the first time that they're taking this tool and making it public outside the Hexens teams and partners themselves, right? So this is a great opportunity. So lot of learnings, and we look forward to all your feedback. And you're all the top participants from the race, so the Solidity. You've been hopefully looking at a lot of vulnerabilities and exploits. So this querying engine is, at least the first one that I have heard of, right? In terms of DSL, a domain-specific language that's been created. So many of you may have played with some of the other static analysis tools or fuzzers and other formal verification tools, but this is definitely different from my perspective. So look forward to all that in the next 2 weeks, and please stay tuned to all the announcements. I mean, things move really fast, even with the workshop. So there will be, like what I said, they have a whole set of talks planned every other day, I think. And we will also share more logistics about where you can ask more questions. There's obviously access to the tool that will be provided to the final 32 participants. So lots of things happening. So please, please stay tuned and keep your next 2 weeks open for more participation. So with that, let me stop the recording for now.